For the subscribers who are mainly residential, cable modems, which were based on cable TV, provide very good utilization of the already available coaxial cable. Similarly, the widely adopted and used plain old telephone system lines, such as the unshielded twisted pair UTP, can also be harnessed and utilized to provide internet connectivity to the subscribers who otherwise use the ports for telephone connectivity. This technology is called DSL, the Digital Subscriber Line. In this module, we shall look at the primary motivation that led to the adoption of DSL as one of the growing and in vogue technology, which is competitor in the overall market for the internet traffic for residential subscribers. Then we'd look at the architecture, and finally we'd look at the variants of DSL. Digital subscriber line is actually a group of technologies which is based on existing copper wire, specifically the unshielded twisted pair. DSL is based on certain assumptions. The first one is that there is availability of discrete multi-tone line code. It means that the UTP has the support to carry frequencies which are higher as compared to the voice spectrum, which is centered around 2.5 to 4 kilohertz. And then the UTP is also widely available. So if you are looking for the DSL based internet connectivity from your home, you need to check up first with the DSL companies if the right kind of UTP is available in your neighborhood. If it is not, then you would not be able to avail the DSL based internet connectivity. DSL can provide up to 7 megabits per second, which is good enough for voice and video requirements. The bandwidth allocation is quite flexible because depending upon the user requirements, the discrete multi-tone, which is similar to OFDM, assigns that many bits and frequencies to each individual user. Unlike cable TV based packet networks, DSL is dedicated. That is why, as the number of users grow, we do not observe a degradation in performance. The architecture of DSL can be considered as comprising two parts. Here we have the network provider part. The network provider is providing the services through DSLAM, that is Digital Subscriber Link Access Module. Here, what we observe is that the DSL part is based on modem bank, which is it provides one-on-one connectivity to the modems in the residential area. Then we have the backward compatibility for plain old telephone system, and then we also have a data concentrator that concentrates traffic coming in and leaving for the T1 and E1 lines. But for the sake of our reference, we are mainly interested in the modem bank. This is the network side. And on the customer premises equipment side, let's say it could be either a residential user or an enterprise. It could have either FDI, that is feeder distribution interface based connectivity, or it could have an integrated access device. In the former case, what we see is we have our own PC with a modem connected to it. This modem directly communicates with the modem bank here, and it uses the digital multitone to carry OFDM kinds of signals between these two modems to carry large and high-speed traffic. Then we also have a telephone, and the usual telephone data or traffic is carried through the same FDI to the ports line interface, on the same feeder distribution interface. So the splitter keeps track of the distinction between if the traffic is coming for PC, that is, if it's data traffic, or if the traffic is voice meant for the telephone. If we look at the integrated access device, it encompasses everything that is the FDI, the splitter, and everything, and it directly connects to the workstation and the telephone. So we have alternatives of IAD or FDI-based connectivity for the digital subscribers on the DSLAM. Let's look at the family of DSL. In Pakistan, we are using some specific variants of DSL depending upon the subscriber and the operator. Various kinds of DSL technologies are available. For instance, let's look at HDSL. HDSL provides 1.544 megabits worth connectivity, and it also provides 2 MB connectivity. Then the distances which are limited from the exchange, that is what we call the DSLAM, to the residential side is limited to 12,000 feet or 4,000 meters, or we can say almost 3 to 4 kilometers. And it has to have a certain standard. If the cable is not on that standard, then this HDSL cannot be provided. So main application for HDSL include the T1 and E1 replacement. So instead of using T1 and E1 lines, we can use HDSL. Similarly, we can also look at some other variants. An interesting variant is ADSL. It has a more range that is 1.544 to 6.1 megabits per second downstream and 640 kilobits per second upstream. The reason for providing this asymmetry, that is asymmetric digital subscriber line, is to provide different kinds of flavors and packages to the users, because mostly the users are interested in downloading content, but what if they are also interested in uploading content? So for uploading, 640 kilobits per second is provided. It has again its own limitations in terms of distance from the DSLAM. The applications are the residential and small business internet access and multimedia services. So you can run various Skype and other kinds of interesting Google Talk applications if you are using ADSL or HDSL modems.